right, Jackson, I hope you get to feeling better soon, bud. All right, so nice, aesthetically pleasing, continuous slant, but mathematically, what do we call a slant? It still starts with an S. Leah? The slope, which you should be able to figure out if you look at the title of the notes for today. It's the slope of a line. So how we determine the slope of a line is a really easy process, and because of that, slope was one of my favorite mathematical topics because it makes sense. When you see things out in the real world and you can like kind of envision a coordinate plane overlaid on top of it, and you can see a grid, the XY axes and the grid that we make off them, your eyes are very good at recognizing steepnesses comparatively, like what is steeper than the other, what has a greater slope. And also, it's really good at if you determine whether something's proportional or not, based off, it has to be a straight line, but to be proportional, it also, anybody?
Goes through the origin.
Through the origin. So when it's not through the origin, it can still be linear, but not proportional. So slope of a line, we have a real easy formula that we call vertical change over horizontal change, or way easier than talking about that, rise over run. Sorry, Nate stole it before you got there. So on your notes it says rise over run, but I want you to draw the division bar between them, because we really take the amount that we've gone vertically and divide by the amount that we've gone horizontally. Now we always want to talk in terms of bottom to top and left to right. So if it's a negative value, that means I've either gone down or I've gone left. Sheev?
Wouldn't that be the same as delta?
Yeah, so that's the exact same as our delta y over delta x. It's just another way to look at it. So if you want to, my triangles kind of look bad there, make it delta y over delta, sorry, that should be a y, over delta x, because delta again means change in. So a lot of times in science, you'll use delta t for change in temp or change in time, depending on which one. A lot of times you'll work with a lowercase t and an uppercase t. So when we talk about this line right here, we go from a point to a point where they intersect the grid lines. Do not choose a point in between grid lines. It doesn't make any sense. It's too hard to approximate. So find one intersecting point and another intersecting point. You can either start by doing the left to right or the bottom to top. It doesn't matter. Since rise is on top, we normally start by doing vertical first. How vertical do I have to go to get from this point to that point? I got to go up 3. How horizontal? I got to go over 2, which makes my slope 3 over 2. Any questions on how we determine the slope?
For science, it seems much harder.
I could rewrite this as a decimal value. I could write 1.5. But which do you think I like better? Do you think we like the fraction better or the decimal? The fraction. This is one case where we very much would rather have a fraction than a decimal. So always, if you have the choice with slope, use a fraction. So we need to identify the slope of these 3 lines. I think you guys can probably do this at this point. Take 45 seconds. We'll give you 15 seconds per line. Determine these slopes. Twenty seconds remaining. Three, 2, and 1. Not the right set. Where are your cards? All right. Yeah, I couldn't find them. They weren't in the rack. You ready for this? Really, you've had a minute. Now, Carrie, do we know what the slope is for that first line right there? Passing off. Seth?
2/3.
2/3. So from this point to that point, think first, what is my vertical change? You can also look, my first x was 0. Or sorry, not my first x, my first y, because working vertically, we're dealing with the y. And my second y was 2. So I know my vertical change there is a +2. And you could also come over and do that vertical change and then draw how far it takes to get over. or you go up and then draw how far it takes to get over. Either way, my horizontal is 3, so this becomes 2/3. Rock, yeah.
How though? Like, where?
So we're looking at the rise
Yeah.
divided by the run, which is really vertical over horizontal, right? So from an intersecting point, stop, I want to erase. From an intersecting point, which we like the origin, it's nice and easy to work with. So to get to this point, even if I follow this line, what is the actual vertical change that has been taken? Well, there I hit my first vertical and my second. So I've gone up a total of 2. I've also gone over, but I've gone up 2. So we know my vertical is a +2. And then I see, well, how far have I gone horizontally? Well, if I start my horizontal, I hit 1 right there, 2 right there, and 3 right there. So my horizontal change has been +3, so it's 2/3.
Okay. Do you simplify stuff?
What do you mean?
Like,
If you
so
had
if
like
you
4/6?
got- right. If
Yeah,
you
you always do.
simplify.
So what Nate is asking about is, what if instead of using this point, Nate had moved on and used this point instead? Well, there, my rise would have been a +4, and my run would have been a +6, but 4/6 simplifies down to 2/3, so we always reduce our fractions if possible. It just makes things simpler. It wouldn't necessarily be wrong, it wouldn't at all be wrong, but we always like to work in reduced or simplified form. Pranav?
So if in digits, if we answer the question like a 4/6 instead of 2/3, would that be considered
I
wrong?
don't know. It might count it as wrong because it's not in simplest form. And a lot of times in the blue text it'll say simplify your answers, reduce fractions. It'll say that sort of
You
stuff.
just have to read. You can't just like skip through.
Yeah.
Because that's what I do all the time. When you get the answer.
Moving on. Shahib, what about my next one? Do we know the slope there? 2/1, you're saying?
I got
But you had a question mark in your voice, so let's check it out. I'm going to go from this point to that point, and I can either go over then up, or I can go up then over. I kind of like to go over then up because I can see it easier in a way. If I go up, then my hand kind of blocks stuff. So how far did I go over? 1, 2, 3, 4, 5. How far did I go up? 1, 2, 3. So really, this slope becomes my 3, my vertical change, over my 5, my horizontal change.
Can I do the next one?
I'm going to capture this because I got to scoot over. Sure, Nate, because you asked so kind. Oh, come on. What's my next one?
So, okay, I don't know if it's negative or not, but that's what I did. So I got 1/4.
So my horizontal, I went to the right 4, so that's a +4. But since I went down, that's a -1. So it'd be a -1/4. Like we mentioned briefly yesterday, all lines that are increasing left to right have a positive slope. But here, as I go left to right, I'm decreasing. I know my slope's going to have to be negative. Now, the other way that I could have looked at this is from this point to this point, I go up 1, but I go left 4. So I could also say 1/-4. Because on any of these, I could start from my right point and go to my left point, but I went down 3, right 5, -3/-5 simplifies to 3/5. So it doesn't matter whether you work right to left or left to right, but you have to be careful of the positives and the negatives. Does that make sense? It's kind of like whether you're walking up the hill or down the hill. It doesn't change the steepness of the hill. You know, like,
Yeah.
I'm trying to make an analogy that makes sense, but making analogies on the fly does not always work as well. So here you're going to have to write more into your notes. We again know change in y coordinates over change in x coordinates, but how do I find the change in y coordinates and the change in x coordinates? Because what if we don't have a line? What if you don't have a graph? You don't see anything. So imagine you don't have this line, You only have the points -4, 3, and 2, 0. We are going to now apply names with a sub. There's really no better way to say it. So when we start to share x, y, x, y, x, y, we have all these points that are x, y. We need to differentiate them somehow. So I now, and I like to start left and go left to right, I now make this my x1 and my y1. That's my first point that I'm looking at. I make this point my x2 and my y2, and that's my second point that I'm looking at. X.
You just give it different variables.
Because we can't. It's still an x value and a y value. We can't say it's like p and q because it's on the graph. We're talking about something that's in the physical coordinate plane. It has to be an x value and a y value. Then we could have x3, y3, x4, y4. We can have as many as we want. So really, we did give it a different variable. But instead of changing the letter, I changed the sub. And this number doesn't do anything. It's just like another variable. So x1 and x2 are two different variables in a way. What you need to do then, off to the right of your change in y and your change in x, we would do that mathematically by doing y2 minus y1, that's how you find the change or the difference in something, over x2 minus x1. y2 minus y1, x2 minus x1. Now, it will work in the other order. If you take y1 minus y2 and x1 minus x2, that will work. But normally, we do it like this because if I'm working from the left to the right, this will make my math easier. So when we do that, I had, and notice they're actually in the other order. They're doing y1 minus y2 and x2 minus, or x1 minus x2. It screws me up when I say it in the other order. So they actually made this their 2 point and their 1 point, or they're doing it the other order. It doesn't matter. All you have to do is make sure you start with the same point. So what I want you to highlight or circle or something is that the 3 and the -4 come from the same point. So now your point essentially should be stacked over top of itself. Then I subtract away the 0 and the 2. Those come from the same point. So you always want to look, is my point vertically still together? That's all that matters. Because if I do the addition, or sorry, if I do the subtraction my way, I'm going to do the y2, which I had as 0, minus the y1, which I had as 3. And my x2 was 2. My x1 was -4. Make sure that when you have minus and negative, you either write it out or you go ahead and change that sign. This becomes -3 over 6. What's -3 over 6 simplify to?
-1/2.
-1/2. Same thing they got there. Notice instead of finding my negative on the bottom, I found my negative on the top, but it doesn't matter. If I have one negative, it makes it negative. Does this make sense that the order is exchangeable, but you gotta make sure you keep your points together? Because the biggest mistake will be somebody will come in and they'll try to say, okay, 3 minus 2 and -4 minus, like they get things all jumbled up. I like to start by just taking a point and stack it vertically. Use the x and use the y, then minus away the other point stacked vertically. So, if we are given these points, try it out. I will walk through one. If you want to watch me, I will walk through one up here. any questions on what I did? I made my first point my 1s, my second point my 2s, x2, y2. So if I look at my second point, to start with, I put the y on top and the x on bottom. Then I subtract away my other point with the y value on top, the x value on bottom. But notice I have to subtract away a negative, so it actually becomes addition. Try B and C on your own. If you're having any struggles, please stick up a hand and ask for help. Jackson, your card is next, dude. We're missing you. Let's call him up. Jackson, what do you think the slope is?
Yes.
I have his cell. We've been texting while he's been sick. So I'm going to embarrass him because he's not here and I don't know if he'll watch the video. Sorry, Jackson. Jackson's been doing awesome because when I get here in the morning, within about 15 minutes of me arriving, he's been texting me and saying, hey, I'm not going to be at school today. What am I going to miss? So then I've been able to say, oh, by noon, I'll have the videos uploaded and I'll know, really well. But I essentially this morning said, we're probably going to cover 2 units again. We're probably going to do the same thing. Watch the videos, fill out the notes, don't miss anything. So when you guys are sick, communicate with us. We'll do what we can to help you.
Did you get my email, Mr. Hudson?
Yeah, I emailed back to you this morning.
Okay, I haven't looked at it.
Yeah, when you email me at the end of the workday, I don't always see it because I went to
Mr.
dinner
Williams
last
to the
night.
office, please.
Ashton is sick too. Ashton, feel better, bud. Grace.
Do -5 -1.
Sweet. So my delta y on top is the -5. She made that her y2. And my 1, my y1. So my delta x on bottom then?
8 -6.
Yeah, 8 minus 6. Notice the 8 and the -5 are still together. The 1 and the 6 are still together. They're both being taken away. Now when we do that subtraction, what'd you get?
-6 over 2.
-6 over 2, which really simplifies to?
-3.
-3. In this case, we don't need to leave it a fraction, but we could by just doing -3 over 1. But we don't need to leave it as a fraction, because if I just say the slope is -3, I know it's going down pretty quickly. -3 is kind of a steeper slope. Zach?
Can I try the next one?
Sure.
Because I also have a question.
Yeah.
So 4 minus 1, and then 4 minus -2.
No, wait. Where'd you get this 1 that you subtracted away? Because if you make this your y2,
Yeah.
then your y1 is 4.
Yeah.
So this actually needs to be 4 minus 4. And then my x2 would be my 1, and my x1 would be -2.
Okay, that's what my question is.
Yeah.
Wait, no. Couldn't you just do like it doesn't matter. 1 plus 2?
Yeah, exactly. But what's my numerator become?
0. So that means there's
So this is when I really wish that Ashton was here. Really, really. Ashton, if you're watching this video, I'm missing you. We're going to talk about the, Yellowstone. I think it's Yellowstone.
Cookie Monster.
No. So there is a climbing scale. When you go to climb, and we're looking at doing this for Discovery Day, when you go to climb, there's a scale of how hard the wall is. Right now, we are all on a 0. The scale of the flat ground. How much slope do you change when you're walking down the hallway of the school?
0.
You don't go up and you don't go down, right?
No.
Well, you would assume that it's flat, at least relatively.
Yeah.
So when a line doesn't go up and doesn't go down, its slope is 0. And when we think about applying this to our y equals mx, if m, my slope, is 0, that's going to be 0 times x. So that all becomes 0. So that is where, sorry, not plus 0, that plus b comes into play. This would just be a horizontal line if there's no b It's at 0. It's the horizontal line. It is the x-axis, essentially. If there is a b value, it's a horizontal line wherever that b value tells you that you are. Whether you're above the x-axis, below the x-axis, you're just a horizontal line. Pranav?
So you can't divide by 0, but you can divide something with 0, right?
Yeah,
Because
you can divide with 0, like in the numerator. You cannot divide by 0. It cannot be in the denominator. And we're going to look at one of those situations. What sort of line gives us division by 0 and what happens then? By the way, then I did not mean to capture again. Then the difficulty of the walls goes up to a 1 is like a gentle slope. A 2 is like, it goes by degrees, but then it gets to a point where you have to have assisted, like you would need a stick or something to help you get up the slope. And then it goes to where you would need, it may not still be straight because that's a 5, but a 4 is like a wall that angles into itself. So you could climb up it and you could probably do it without protective equipment, but at a gym or somewhere you would have to. And then 5s are vertical or coming out off the wall. So if you climb and you're coming away from the wall, you're on like a 5'10" or a 5'11", like something difficult. Zach?
Wouldn't you still, like, on the one we just did, get the same answer if you did 1 plus 2 on the bottom?
Yeah, I did do 1 plus 2 because I got 3.
Yeah, but
Because minus a negative turns
why
into.
do you have to write it like that?
You don't have to write it like that. I just did.
Oh.
To show that it's minus the other x. I'm showing it like that so you see subtraction on both the top and bottom. But then when I do the math, it is addition. So you could write it as addition as long as you remember in your head, I'm actually subtracting, but since I subtracted a negative, it became a positive. Yeah?
Have you ever thought of just like free climbing up a mountain like some people will?
No. Because I like my life. I will always have a belay, like a person on a rope. I will always have that. A line with a slope of 0 is horizontal. So this equation would be y, up here on your notes. This equation would be y equals 0 times x because the slope is 0. But it has a y-intercept of 2, so that would actually be plus 2. So really, this line is y equals 2. Whenever you see a y equals, that indicates the horizontal line. So now we get to this situation where we have a horizontal line, because if we're going to work with horizontals, what about a vertical? So if I take 2 points from this vertical line, let's say this is 2, 3, and this is 2, -3, and I do my delta y over delta x. My delta y is -3 minus 3. My delta x is 2 minus 2. I get -6 over 0. And this breaks me. I cannot divide by 0. So this slope here is actually what we call undefined. You cannot define the slope of a vertical line because it's not sloped, it's not slanted, it's vertical. Its slope is essentially infinity. Because if you think of the vertical change over the horizontal change, compare, actually let me capture that real quick. If I use this gap, I get 2 over 0. If I use this gap, I get 8 over 0. If I would use that gap of my vertical line, I'd get like 20 over 0. Doesn't matter how much you change vertically, you never change horizontally, so it's always called undefined. Because we cannot divide by 0. Literally, that answer is undefined. There's no definition for dividing by 0. Question?
Wouldn't the slope be 0 because it's a steady slope?
No. It's an infinitely large slope. We cannot stop going. We cannot stop changing vertically. There is no point that I can stop changing because I'm just continuing forever. A zero slope, this is where most people get confused, means that there's no slope. There's no change vertically.
It's like
It's the hallway. You're walking on flat ground. There's no slope. There's no pitch.
It's like sea level.
A undefined slope is I cannot express the change that's happening because it's infinitely large vertical change for absolutely no horizontal change. So essentially this slope is infinity over 0, which is completely unfathomable. Is that a little better now?
Yeah.
Do not let your brain think that this is a zero slope. Zero slope is horizontal. So which roof is steeper? Roof A with a rise of 12 and a run of 7. A with a rise of 12, a run of 7. Or B with a rise of 8 and a run of 4. Well, what's B simplified to? 2. Huh, that was funny. Would this be more or less than 2? Less than 2. It would be, if I look at it in mixed number form, it would be 1 and 5/7, which is less than 2. If my slope, and we would never write slope like this, we would either put it as a decimal or leave it as 12/7. But just for comparison, 1 and 5/7 is less than 2, so it's less of a slope. If we're looking for which one is steeper, roof B would win. It has a steeper pitch. It's going up more for the same horizontal change. Because if I evaluated this in sevenths to compare with my 12/7, this would be 14/7. It goes up an extra 2 every horizontal change that we look at. Does that make sense how I could compare these? Moving on. Was there a question? Yeah?
This is off topic.
How surprising.